When the ground acts as the lowest border of the opening, the entrapment exception applies. Why? Because the ground covered with a protective covering is movable. These exceptions can occur at the bottom deck of a stepped platform, at the bottom rung of a step ladder, or the bottom stair of a staircase. How about synthetic surfaces? Does the entrapment exception apply if the lowest border of the opening is a synthetic surface? The current CPSC guidelines would not permit an exception because this type of surfacing is not movable. With flexible play components like cargo net climbers, pay close attention to the location where the equipment is anchored to the ground. Often the concrete footers or attachments supporting the flexible components may be exposed and create other hazards. Let's see if we can locate areas on the following pieces of equipment where entrapments may occur. Notice in the picture the small testing probe. It passes through the opening, but it is clear that the larger probe would not fit. Since that is the case, this piece of equipment has multiple entrapment hazards. Entrapments are located between each of the horizontal wooden slats because the small probe will pass through, but the larger probe will not. Take a look at these vertical bars. Why are spaces between the vertical bars in this example an entrapment? Take a moment to think. If you said because the small torso probe fits through the bars, but the large head probe does not, you are correct. If one probe fits through and the other does not, you have an entrapment issue. What about this one? If you said this is an entrapment issue or a hazard, you are correct. Notice the small probe will fit through the red handle, but the larger probe obviously would not fit. Last example, what about this one? If you said this is an entrapment hazard, you are correct. Notice the small probe easily fits through the opening, but the large probe does not. Children's clothing can become entangled in play equipment. Areas that can entangle children's clothing include protrusions and projections that we talked about earlier, and now upright V angles of less than 55 degrees. Since we have already talked about protrusions and projections, let's talk about V angles. An upright V angle hazard is defined as any V-shaped corner less than 55 degrees formed by adjacent components of play equipment. If one leg of the V is horizontal or sloping downwards, the angle is not considered a hazard. Let's take a look at some examples. Can you locate an area on this piece of equipment where an upright V angle hazard may occur? This piece of equipment has two locations where an upright V angle hazard occurs. Notice here where the handrails come up, then bend back down to connect at the top of the slide. That connection point most obvious on the right-hand side of the slide creates an upright V angle hazard. The second, or in this case the same hazard, occurs on the other side of the slide at the same junction. Incorrect surfacing can cause serious injuries. Nationally, nearly 70% of playground-related injuries are from falls. These fall injuries are a result of two factors: the height of a child's fall and the surface material the child falls upon. In order to prevent these injuries, child care centers should provide soft, resilient surfaces under and around stationary playground equipment. Take a look at this picture. Is the surfacing shown here an acceptable surface? The answer is no. Earth surfaces such as soil and hard packed dirt are not recommended because they have poor shock absorbing properties. In addition, grass and turf are not recommended because wear and tear and environmental conditions can reduce their effectiveness in absorbing shock during a fall. The body of playground safety research has identified soft surfaces or surfaces that are acceptable for use under and around play equipment because they absorb the force or impact of a fall. Some surfaces meeting this standard include wood mulch, double shredded bark mulch, engineered wood fiber, fine and coarse sand, and pea gravel. Hard surfaces like asphalt, concrete, or bare ground are not acceptable for use under and around play equipment. Each one of these surface types has pros and cons. Organic loose materials such as wood mulch, double shredded bark mulch, and engineered wood fiber have a low initial cost and are easy to install. They have an attractive appearance and are readily available. However, these surfaces over time decompose, are subject to microbial growth when wet, compact, and can be easily spread. On the other hand, inorganic loose materials such as sand and pea gravel have a low initial cost, are easy to install, do not pulverize, and are readily available. But these surfaces with normal use combine with dirt and other foreign materials, and they may be swallowed up. They may conceal animal excrements and may be blown. So, how much surfacing is enough? The general rule is this: the higher the equipment, the deeper the surface. The depth of the surface is based upon the critical height of the equipment. The maximum height a child may climb, sit, or stand on the play equipment is considered the critical height. Take a look at this chart. The critical height and the type of surfacing used in your playground will determine the acceptable surface depth. For example, if you have a critical height of less than 5 feet, the acceptable uncompressed surface depth is 6 inches regardless of the material. However, if your critical height is 8 feet, the acceptable depth varies. Wood mulch would require 9 inches, while fine sand would require 12 inches. Surfacing at the appropriate depth should be placed around stationary equipment for all distances of 6 feet. This 6-foot area around stationary equipment is called the fall zone. This 6-foot area should be thought of as a no-use zone. By that, we mean children should not park wheeled toys or movable climbers inside this area. Stationary equipment anchors in the fall zone must be covered with surfacing materials and not exposed. The North Carolina Child Care Commission does not require surfacing under movable equipment. However, the 4 environmental rating scales used for star-rated license does call for 6 inches of surfacing under all fall zones. Therefore, movable equipment without surfacing would result in the downgrading of the environmental score. The Consumer Product Safety Commission has also issued a safety alert on plastic climbing equipment. This alert advises child care providers to put climbing equipment outdoors on surfaces such as sand and mulch to prevent children's head injuries. Fall zones may only overlap in certain situations. That would be between 2 swing sets, around spring rockers, and other play equipment that share a fall zone must be less than 30 inches in height. In addition, special fall zone dimensions specific to the following swing types are required: 2-fro swings, tot swings, and tire swings. Child care professionals should remember that swing seats are to be constructed from a soft, flexible material. Do you notice any safety concerns on this slide? Although it's not covered within the North Carolina DCD playground rules, to minimize the likelihood of children being struck in a bay by a moving swing, it is recommended that no more than 2 single-axis swings be hung in each bay of the supporting structure. It is also recommended that for younger children, playgrounds have separate areas for appropriately sized equipment and materials to serve their developmental levels. This particular bay does not have age separation of equipment, and it has 3 swings in one single bay. Take a moment to look at this slide. As you see, the fall zone for the 2-fro swing should be equal to twice the distance from the pivot point to the surface. In this case, 2 times 8 feet or 16 feet for the fall zone. How about tot swings? The fall zone for the tot swing should be equal to twice the distance from the pivot point to the bottom of the swing seat. In this case, it's 6 feet, so 2 times 6 feet is 12 feet for the fall zone. The fall zone for the tire swing should be equal to 6 feet plus the measurement of the distance from the pivot point to the top of the swing seat. In this case, that distance is 5 feet. So 6 feet plus 5 feet is 11 feet for this tire swing fall zone. Let's talk about guardrails and protective barriers. Elevated platforms should have guardrails or protective barriers depending upon the height of the platform and the age of the children that will have access to the piece of equipment. Guardrails prevent inadvertent or unintentional falls from an elevated platform. Barriers prevent attempts to climb over, around, or through the barrier. Elevated platforms intended for both preschool and school-age children, preschool children only, and school-age children only have different requirements. On this slide, the top illustration shows a guardrail, and the bottom illustration shows a protective barrier. The critical height for a platform with a guardrail is measured from the top of the guardrail to the ground. The critical height for a platform with a barrier is measured from the platform surface to the ground. You should remember that critical height measurements for platforms and guardrails and protective barriers differ from the general method of determining critical height in other playground components. Take a moment to read over this chart. Notice if equipment is used by both preschool and school-age children and the elevated surface is more than 20 inches and not more than 30 inches above the underlying surface, a guardrail is needed. See a picture of the guardrail at the bottom of the page. The minimum height of the top surface of the guardrail should be at 38 inches high and the lower edge should be no more than 23 inches above the platform. Also, if equipment is used exclusively by preschool children and the elevated surface is more than 20 inches and no more than 30 inches above the underlying surface, a guardrail is needed. A minimum height of the top surface of the guardrail should be at 29 inches high and the lower edge shall be no more than 23 inches above the platform. Also, if equipment is used exclusively by school-age children and the elevated surface is more than 30 inches and no more than 48 inches above the underlying surface, a guardrail is needed. The minimum height of the top surface of the guardrail should be at 38 inches high and the lower edge should be no more than 28 inches above the platform. Now let's take a look about when protective barriers are needed. If equipment is used by both preschool and school-age children and the elevated surface is more than 30 inches above the underlying surface, a protective barrier is needed. The minimum height of the top surface of the protective barrier shall be at least 38 inches high. If equipment is used exclusively by preschool children and the elevated surface is more than 30 inches above the underlying surface, a protective barrier is needed. The minimum height of the top surface of the protective barrier shall be at least 29 inches high. If equipment is used exclusively by school-age children and the elevated surface is more than 48 inches above the underlying surface, a protective barrier is needed. The minimum height of the top surface of the protective barrier shall be at least 38 inches high.